Two cars leave at the same time in the same direction. 40 and 52. How long till they're 48 miles apart? What equation do we always use in the travel? The dirt. Distance equals rate times time, right? Okay, and then we always have 6 boxes, 2 underneath each letter. 2 D's, 2 R's, 2 T's, right? This is, so the 40 and the 52 those are miles per hour. Is that a distance? Are those distances, rates, or times? Rates. Yeah, those are rates. Those are speeds, right? Miles per hour. So 40 and 52. 48 miles. That's a distance. 48 miles. Do I put it in both boxes? One of the boxes? What do I do with that 48? I leave it out? Good, right. Why? Why would it be wrong, not true, false, make-believe, fairy tale math, to put the 48 in, say, that box? Why is that just not what the words are saying? If you put that 48 there, that means the first car went 48 miles. That's the distance the first car went. That is not what they're saying. They're not saying, hey, that first car went 48 miles. That's not what they're saying, is it? They're saying, in how many hours will they be 48 apart? They're not saying car 1 went 48 or car 2 went 48, huh? They're saying they're 48 apart, right? In other words, they started going the same direction, and one of the cars was just faster than the other and got further and further ahead. Right here, I'll do the movie. Ready? We'll do a video to go with this audio. Vroom, vroom, vroom. Sorry, I'm just being goofy. All right, they take off. One's faster than the other. They're both traveling, but one's faster, so the gap between them just continues to grow. That's what they're describing, huh? Two cars start at the same time, same direction. One's faster. The gap between them just grows and grows. How long till the gap between them, the distance between them, 48 miles apart? Huh? So that doesn't mean either car alone went 48. Actually, they went further than 48, huh? That means the gap between them is 48 miles. So that's why I can't put that 48 in either distance box. It's not either car's distance alone. It's the gap between them. All right, well, anyway, so I can't do that. Well, then I just save the 48 like you said. That's right. What else am I going to put in these boxes then? I need these 2 boxes. What are those 2? X and X. How do we know they're both X instead of XY? The times are the same. So they get the same letter, don't they? That makes sense? If they didn't say that, you're right, I'd have to do XY. But the times are the same, they're both X. All right, once you've got 4 boxes, how do you get the front 2? Yeah, because D equals R times T, huh? That's what the equation says. So this is 40 times X, and this is 52 times X, isn't it? Is that good? Yeah, and then you subtract 52X, you got to put the bigger one first, is 40. Now why? Why do I subtract? Well, two ways. First off, just look at the picture here. However far this one went, that's 52X, he's the further one. Take away how far this one went, 40X, that difference is 48, isn't it? The subtraction, the difference in their 2 distances is 48, right? By the picture. I also try to give you the memory device to help. Same direction subtract. SS. Same direction subtract. I tried to help you with that. So you might want to put that in your notes on your 3x5 card for, when's our exam? When is our exam? It is Wednesday, right? Exam number 5. Now, it is Wednesday. You guys are going to do good on this exam, right? You guys are my bright and shining stars. Up to exam 4, you'd been the highest score I'd ever had on Math 201 class in my 10 years here. So finish strong. You can drop one exam. So if exam 4 was bad for you, no problem yet. But if you have a second bad exam, then one of them is going to count, right? The final will replace your lowest exam. So you can still let the final replace exam 4 if that was a hard one like it was for many, many people. But you can't do too bad. Exam 5 is almost as hard as 4. People do badly usually on 5. I'm not trying to discourage you. I'm trying to encourage you to study. Study hard. Go over that practice exam again and again and again. Go back over the homework. Does that seem crazy? That's what it takes. All right. So solve this thing. 12x is 48. I just subtracted. Divide by 12. X is 4. In how many hours? The time, 4 hours. 4 hours. Is that good? You good with that? Questions I can answer? All right. Let's go then. All right, square root of x equals 2. So this section, 8.5, these are our last two sections in chapter 8. We're almost done with the course. We finished chapter 8 today. Exam on Wednesday. Next week we'll do, on Monday, 9.1, 9.3. And then Wednesday we'll do another section called the appendix, Appendix A, and review for the final. That's it. Final's like 2 weeks from today, right? Yeah. 2 weeks from today. Right now, in 2 weeks, you'll be taking the final exam. It's the 15th. 2 weeks from today. 15th? Yeah, it's on your original syllabus. It's listed there. It's May 15th, Monday. Monday of finals week, 2 weeks from today. All right, how do we solve that for x? What do we do? We got to get that root off of that x, don't we? Yeah, what's gonna we can't have a root. We want just like a normal x, don't we? We don't want like a root on the x. How can we get that root to come off? Anybody know what will pull a root off of the x? Square. That's true. Which can be accomplished by 2 powering, because that means times another root. And whatever you do to one side, you must do to the other to keep the balance, huh? Right, everybody with me on that? So you 2 power both sides like that. And the 2 power cancels the root. They're opposites of each other. Why are they opposites of each other? Well, if you want, you could see it. I won't write this every time, but I'll write it one time. A 2 power means 2 of them. Root x, what is root x, root x? Plain x. Remember how we learned 2 in, 2x is in, 1 out? So that's why. You don't have to write all this. I won't ever write it again. I'll just say, look, a 2 power cancels a root. And out comes the plain x. It's because that means 2 of them, and 2 in is 1 out, right? On that question, Carl.
Okay, so in the previous time, if we multiplied it, the 2 would be in front of the root then.
Yeah, so we're doing something different. We're not putting a 2 in front. That'd be multiplying. I'm not multiplying. I'm raising to the second power. Good observation. This is different, huh? This is not multiplying both sides. I'm not putting a 2 in front. I'm not timesing it by 2. I'm raising to the second power. So in other words, the other side means 2 times 2, which is 4. Our answer is 4. All right, let's try another one. I think it'll... All right, so root of x plus 8 is 13. All right, so as soon as you see a root, this will be on the exam we take Wednesday. And not only that, guys and gals, it's in that last 5, the kind where there's no multiple choice answers. So you got to know it that well. You got to be able to look at a blank thing, no answers, and just do it. You got to know it that well. That's going to take practice. That won't happen by just today, probably, for 90% of you. Didn't happen for me that way. I almost never understood it after class was over. I had to go home and spend hours sitting in the library and at home and doing these problems over and over and over again. So, square root, what are you going to do when you see a square root on the exam on the last 5 to Wednesday? When you see a root, you got to do, what's the opposite of a root? What's the antidote, so to speak? The 2 power, yeah. So the game, here, let me just write the plan for a square root. Number 1, get the root alone. It already is on this one. And then I'll just write parenthesis 2 power, parenthesis 2 power. So that's the plan.
Is it because the equal sign that you need to raise it?
It's because we got to get rid of that root symbol.
But I mean, the equal sign going with it, what difference is that compared to the last section?
Yeah, the last section there were no equal signs. And we weren't trying to get rid of the root.
Okay.
Does that make sense? So the whole deal is to get x alone. They're asking me to get x. They're asking me to solve it, which means x alone, right? That's what it means to solve an equation. Find plain, normal, regular x with no root on it at all. Does that make sense? So I have to get rid of that root. It's a good question Carr's asking. Is everybody with me on that? Do you see? Because I think I like that kind of question because that's what we need to think in order to remember on Wednesday. Does everybody see why I'm even doing this? That's a good thing to think. Why am I doing this 2-power thing also? Because they're asking me to get the root off the x. Where are they saying that? Well, they're saying solve. What does solve mean? Plain x, not root. Plain x. That's what we always do when we solve, huh? Right? That's not news to anybody, right? Whenever we solve, we want plain normal x equals whatever it equals, right? So when they say solve, you should think, oh, they mean plain x. Oh, I got to get rid of that root. And what gets rid of the root? The 2-power. Does that make sense? So what we do is we put the parenthesis, 2-power, parenthesis, 2-power on both sides. And what happens? The 2-power tears off the root. On the other side, what happens with the 2-power on the 13? Yeah, 13 times 13. So you multiply that and you calculate, what is that, 169? Yeah. We good so far? Hey, I've got an important question. Why did I multiply two 13s? Because it's second power, right? Well, then why didn't I do that on the 8? Right, there was a 2 over here. Why didn't I 2 the 8? Why didn't I go 8 times 8, 64? Why did I do it for the 13, but not for the 8? Because why? Because the root canceled out the 2, and he wasn't there anymore. Does that make sense? There's no root on the right side over the 13, protecting him from being squared. But on the left side, the root cancels the 2. That's the only reason. Otherwise, you would do 2 8s. Does that make sense? Do you see how on one side the 2-power gets canceled by the root? And the other side, it doesn't. So you have to actually do 2 of them. Making sense? Yeah. On that? And then, now how do you finish solving this equation? X plus 8 is 169. Minus the 8, right. Now it's just regular stuff, huh? 161.
That's the answer?
That's the answer. So that makes sense on that. So when we see a root symbol, we get rid of it with a 2-power. 2-power cancels the root. Questions I can answer? Be good. We'll try another one. Okay, so 1 plus root of x minus 5 is 9. So what's the root plan? Step number 1 is root alone. Step number 2, second power both sides. So step number 1, you've got to get that root alone before you second power. What do I mean alone? No, I mean get rid of that 1 that's over there. See how, here's the equal sign. See how the root is like, hey, I don't want this 1 over here with me on my side of the wall. Get rid of that 1 first. Subtract 1 from both sides, huh? That's when we get rid of that positive 1. Subtract 1 from both sides. So yeah, we have to always get the root alone first. So first get the root alone. Subtract 1 from both sides, and it's gone. Are we good to there? And then what do we do from there?
Power of 2.
Now we 2 power both sides. Rooting cancels squaring. Eight squared, 64.
Then you add 5.
Then add 5. What's that? 69?
Yeah.
We got it. Is that okay? See how we first get rid of anything that's with the root. We get it alone, then we 2 power again. That tears off the root. Other side, it squares it. Why don't we square the 5? Why is it 5 times 5 is 25?
Add the root on
The root cancels the 2, so it can't square the 5. Right? Everybody seen that? So the main point is roots and squares cancel each other, huh? Does that make sense? They're opposites. They're like a poison and an antidote. It neutralizes it, right? That's kind of like what they are, what they do. Is that good? Questions on that one? All right. So root of 5x minus 5 and root of x plus 12. So we got a root on each side. So we got to get rid of those roots. So what are we going to do? 2 power them, huh? Let's go ahead and 2 power both sides. Parenthesis 2 power, parenthesis 2 power. So what's going to happen with those 2 powers?
cancel out.
Yeah, they're both going to cancel so that nothing will actually be squared. It's just a canceling of the roots. Huh? Everybody good to there? Just the 2 powers cancel out the roots. So which is nice, huh? Now we got rid of those roots, so we can just go back to regular. Now, do you remember how to solve? Let me let you take it from there. See what you remember. It's a good little review. We've done this before. You know where you have x's on both sides? How to solve those kinds of equations? Take it from there. See what you can do. I'll give you a second.
That's a lot easier than I thought it would be.
Good? Okay. So what do you do when there's x's on opposite sides? Do what's that? Yeah, move one of them, huh? Or get rid of one of them. Exactly. You don't want 2 x's, huh? You want to get rid of usually the lower one. Usually get rid of the lower one. So subtract the x from both sides. For example, it's probably the best thing to do, right? That'd be 4x minus 5 is 12. Is that okay? Like that? And now keep going. What do I do next to solve for x? Add the 5. Last step. Divide by 4. There we go. Is that okay on that one? It's making sense? Give you a second to think on that. How are we doing? Is that okay? 17/4. So we get. So what's? So I hope the main plan. So because again you're going to see it on the exam Wednesday, the after tomorrow, and it won't have any multiple choice. You just have to remember. So when you see a root, think 2 power, right? 2 power both sides. to get rid of the root. That's the main thing we're doing, is when you see a root, 2 power, both sides, to get rid of that root. Give you a second. Wander out. You know, if I can help. I'm free to check if those are in, Jeff. Yeah, it's not packaged, but yeah, you're totally right. Just subtract x and add 2. Because you gotta use your base whenever you see what else is. Whenever you see
Because the 4 and negative 3 is here.
Yeah.
Subtract the 4 from this. 0 plus 4. Subtract the 4 from this end. Negative 7.
Right. Just look at this and see how
Same thing, it's no solution.
So 0.
That's B. No solution.
Oh, this is a weird one, isn't it? Oh, I didn't realize. Yeah, you're right there, and it's just a no solution. Yeah, I didn't realize it was a weird one. Sorry, I shouldn't have spent so much time. I didn't even think about it till I looked at somebody's paper. That's right, it's a weird one, it's just a no solution. Right, because the y's vanish, right? Yeah, it's a weird one. I'm not going to put one of those in the test. 2 power both sides, rooting cancel, squaring. You get to here, and you like them, huh? So then subtract 3y, and then it's like, uh-oh, all the y's are gone, right? You just have 4 is negative 3. That's not true. No solution. Yeah, when the letters vanish, you just have numbers that aren't equal. It's no solution. Not going to be on the test. All right. Okay. All right, let me help you with this one. This one's going to have a little more complexity to it. So say you saw this on Wednesday's exam, day after tomorrow. What would be your first thought when you see that root?
Cancel it.
2 power, right? 2 power, but get rid of it with the 2 power on both sides, right? So let's do that, same thing here. So now remember when you do, this is where it's going to be kind of important to remember to put parenthesis 2 power, parenthesis 2 power. And not, yeah, just do that, you're good. And now, how does a root and a 2 power interact? They cancel, don't they? They cancel each other. So that's just a regular x minus 2 over there. Are we good? What happens on the other side? Well, you gotta write 2 of them, like that. Does that make sense? Now hold on for a second. I really want to help you with that so it'll sink in. Why is it? Let's ask a couple questions that might help you think more clearly about it. Why is it I'm writing 2 of the x minus 4s on the left side, but I didn't write 2 of the x minus 2s on the right side? I only have 1.
And no square root.
The root canceled out the 2. Same answer. I just want to make sure that's really coming home for you. Right? Do you see why there's not 2x minus 2s on the right side? Because the root canceled the 2. He can't do his 2 thing anymore. He's gone. The root canceled it. But on the left side, you got to do 2 of them. Because the 2's still there. It wasn't canceled. Is that good? And you have to actually foil the left side. Really, really, really common mistake. Everybody hearing me on this? This is a super common mistake, which like, I don't know, maybe 40% of the class, maybe 50%, maybe half, makes. Instead of doing this, they'll wrongly go, oh, it's just x squared minus 16. They'll just square the x, square the 4. That's not true. You can't do that. You have to actually write 2 of the parentheses and FOIL. So remember that. You can't do that. You have to write 2 parentheses and FOIL. Real easy mistake to make because it kind of looks like that, doesn't it? But watch out. Got to write 2 parentheses and then like FOIL like this. X squared minus 4x plus 16. Everybody good to there? Was that too quick? So I just did the FOIL thing we've done before. First to both, second to both. Is that okay so far? I just did first, so the x went first, and he went to both of the other two. And then the -4 had his turn, and he went to both of the other two. First to both, second to both. Okay. So we good to there. Now, this is where, I can't remember, have we done this before? Yeah, I think we have. It's been a while, though. It'd be a good review. What do we do when we see x squared? That's kind of weird. Yeah, get a 0 and then factor. Yeah, let me write that. When you have x squared with an equal sign, step 1 is get a 0 and then factor, like with the parentheses kind of thing. Do you remember that? This is where these get hard. There's a lot going on. So do you see how x squared has suddenly showed up and we haven't had it so far today yet? First problem to do that. So when you see the x squared, did I say it's like a sea monster, rears its ugly head? Yeah. Okay, I did. I thought we've been doing it. Yeah, so there it is again. It's been a long time since we've seen this monster, but there it is again. When x squared just rears its ugly head all of a sudden, you go right into that, get a 0, and factor. Okay, so get a 0. Where do I get a 0? Well, over here, the opposite side from the x squared, I have to make the other side 0. So how do I make that side 0? We'll just do the opposite of everybody. Minus x and plus 2, and they'll both go away and we'll have 0. But whatever I do to one side, I have no choice but to do the same thing to the other, right? The equal sign is like a wall. I got to keep the balance, huh? So minus x and plus 2 to both sides. It makes 0 on the right side. What happens on the other side? X squared minus 9x plus 18. Is that okay there? We good so far? Do you see why it's minus 9? Because it's minus 8 and minus 1. Like that. Good to there. So step 1, get a 0. Check. I got a 0. Step 2, I'm supposed to factor, like the parentheses. I'm looking to put x's in the front. Remember, two numbers that multiply to be 18 and add to be minus 9. What times what's 18? What can multiply to be 18? And can still make a 9 in the middle. Yeah, 6 and 3. Use your calculator if you need to. 6 and 3. Right? 6 times 3 is 18. And what signs do they need to make minus 9 in the middle?
Negative and negative.
Both negative, yeah. And the two negatives do multiply to be positive. And they multiply, they're positive 18, right? We good to there so far? Now, I should maybe put a step 3. Each equals 0. Remember how you have to set like each one equal to 0 separately? X minus 6 equals 0. X minus 3 equals 0. Remember how you do each one of these guys separately equal to 0? They each equal their own 0. And then you add the 6 to both sides. So x is 6. Add the 3. It's just going to be opposite signs. Remember how it always comes out opposite? You can just skip all this if you want. And as soon as you see the parentheses, you just go, oh yeah, opposite, opposite, plus 3, plus 6. Oops, off the screen, huh? Plus 3, plus 6 there. Sorry, I didn't realize I was off the screen. Off quite a bit there. Oops. Oops. Okay, so there's our two answers. 6 and 3. We good to there? Now's where I have to tell you, unfortunately, we're not done. And one of those is a bad answer. We have to throw one of those away. One of them's good, but one of them is bad. You have to check your answers on these. These are pretty long. These are pretty hard. You have to check your answer. So, let me just put it at the top. Any square root problem, any square root with an equals problem must be checked. Is that on the screen? Yeah, it's kind of, I'll just say must check.
Is that
Any square root with an equals, you must check your answers. You must check this off the screen. It's crazy. Must check your answer. Okay, so that means I got to go back and I got to check my answer. Both answers. Okay, so let's do that. Coming back up here to the top. First off, I'm going to check which one, the 6? X is 6. How do you check an answer to see if it's really true? Plug it in, huh? Yeah. To both X slots, huh? So plug in the 6, plug in the 6. 6 minus 4 is the root of 6 minus 2. That's 2 is the root of 4. 2 is 2. Yeah, check. That one's a keeper. 6 is a good answer. But how about the other one? Let's check. X, what was the other one? 3? So again, you go into the original. You always check with the original. See, I'm just grabbing the original starting equation each time, and I'm just plugging in the answer. You plug in the one answer at a time for all the x's, right? So now I'm going to plug in 3. Boom, boom. 3 minus 4 is the root of 3 minus 2. Negative 1 is the root of 1. What's the square root of 1? It's just 1. It's not negative 1. Well, this is no. So throw away the 3. The 3 is what we call a false answer. Only the 6 is the real answer to the problem. So that was a lot of work. Yeah, right. It made the equation true. Remember, an answer, something that's a correct answer, a real answer, should make the two sides the same. Does that make sense? It's trying to make equality. Does that make sense what we're doing? We're trying to say, hey, if you plug in x equals 6, does it make the left side equal the right side? And it was yes, 2 equals 2. It made them equal. It solved it. But not the 3. The 3 made them not equal. Does that make sense on that? That's what an answer does for an equation. It makes the two sides equal. You're trying to find what values of x make the two sides equal. So the answer is only the 6. Questions I can answer on that one? So a lot of steps on that, huh? So which problems do we have to check on the Wednesday's test? Anyone that has a square root with an equals. And there'll be 1 or 2, probably 2, on the test Wednesday. Oh yeah, at least 2 or 3. So one good idea is to take the test on Wednesday. As soon as you get it in your hand, look through it real quick. Any problem with a square root and an equals, put a C next to it or something to remind yourself to check. You know, when you get to the answer, you got to check.
So there's 2 of these, so if I get those right, I'm not worried about the test.
Okay, there we go. Let's try that one. I'm going to wander around so if I can be of some help.
You got a person that needs
Let me know if you need some help. Or check your answer or something.
Give me like 5 questions on your calculator.
Did you? Maybe when it came out these bag of tricks.
I should change it. The test you didn't change.
Maybe that's like it.
Yeah, but they get different numbers, but the same equation. Same problem, but different numbers.
So what's the first step?
Power of 2.
2 power both sides, right?
X squared plus 5x plus 5x plus
So parenthesis 2 power, parenthesis 2 power, right? Yeah. And have you noticed one of the sides is always easy and the other side is hard? One of the sides where you've got the root, it'll just cancel the 2, so you won't have to do 2 of anything. But the other side, the root's not there to cancel the 2, so you got to write 2 of them in FOIL. Everybody see the difference? Right? Where the root is, it cancels the 2. The other side, it's not. There's no root. So you write 2 of them. No.
So what did
You want to get rid of the stuff on the other side. You want to get rid of these minus. Because the x squared you want to keep.
Try to get
You want
x
to get rid
squared
of the
equal
other
to
side.
or x squared
From x squared.
plus
Yeah.
or minus
plus x minus 30?
Right.
Oh, 6 and negative 5.
No, okay, so do this. Start here.
6 and
You want to make this 0, right? Whenever you got x squared, you want to make the other side.
5 is 30, right?
So what makes
6 minus 5 is 1.
minus 5? Minus
I put a 1 in there.
But these,
Yeah.
X minus 6.
You plus it,
It's like
you
it-
got to do minus. Make it 0.
So it's what, 6 and negative 5?
Yeah.
Or
Good. And whatever you
can
have
have
one
two
side,
positives.
same thing.
x plus 5 is 0, right? Drop 5.
That'll make 0. So whenever you have
so
x
the
squared,
minus
the other
6
side.
and positive
6. Does it matter?
how? It is.
Yeah.
To be a positive 6 to get
Okay, so you're doing okay.
The
Foil.
no. It's negative 6 plus 5. Negative 1.
Good so far?
It can't be negative.
Everybody good to there? Now, remember what we're supposed to think. Whenever we see x squared, like we're seeing it, right? Sea monster, rears its ugly head, x squared. We're supposed to make the other side from x, not x squared, but the opposite side of x squared, 0. Everybody good with that step? Is that making sense?
5.
So whenever you see x squared, you go, oh yeah, there's the sea monster. What do I do about it? Opposite. So x squared's over here on the right. So over here on the left, you've got to get rid of this. You've got to make this side 0, right? We always make the opposite side from x squared become 0. So how do I do that? Well, I got to do the opposite of everybody over there. Yeah. So subtract 9x and subtract 55. Everybody with me on that? Everybody see what I'm doing? And whatever you do on one side, you have no choice but to do the same thing on the other. And we get x squared plus 1x minus 30. Is that good? And we got our 0, didn't we? We made 0 show up on the opposite side from x squared. And then what?
factor plus
Factor.
x minus 6, x plus 5.
X plus 6.
Good, yeah, so do the factor. I'll let you guys finish it. You want two numbers that multiply to be 30 and add to be 1.
I'm gonna test right now.
What times what's 30?
6 and 5.
6 times 5? 5 times 6? The order doesn't matter, but the signs matter, huh? How do you know what signs to do? Remember my sign rule? The sign that's in the middle, the sign in the middle always goes on the bigger, yeah. The sign in the middle has to go on the bigger, and the smaller is the minus. Huh? Plus 6 minus 5 is plus 1, isn't it? Which makes the middle plus 1. Is everybody good to there so far? Right? Sign in the middle goes on the bigger. And now what are the two answers? -6 and +5. Maybe, I got to check them. But are we okay so far? You just do opposite of what's in the parentheses, huh? Now we have to check. We have to do two separate checks. One for each of those. To see which one's a keeper and which one's a throwaway. Is that good? Questions I can answer before I erase some of that top stuff?
Throw away the negatives.
Is that good? All right. Let me erase some of that top stuff now. I'm going to check up here. First off, I'll check the first one. X is what? -6. So you write out the first equation, the original equation, before anything was done to it, and you plug in -6, plug in -6. So it's the square root of 9 times -6. All right, like that. So there we go. 9 times -6 plus 55. So what is that? If you use your calculator, so root of 1 equals -1. Square root of 1 is 1 equals -1? No. See how that answer is not a good answer? Because it did not make the two sides equal. Did not make the left side equal the right side. Is that okay there? What's that? 9 times, you use your calculator. 6 times 9 is 54. -54 plus 55 is 1. It's all calculators. Just use your calculator there. So 9 times -6.
The graph.
Yeah, so just use your calculator.
Put like this. The x and the y.
Plus 55.
Give like the y.
Let's get the app on your phone. Desmond.
That makes sense. So they did not come out equal, huh? So that answer, I throw away the -6. And now let me check the other one. So same equation, back to the first equation. Plug in 5, plug in 5. Square root of 100, which is 10 equals 10. Yes, that's true. So 5, so the answer is not 10, the answer is just the 5, which makes both sides 10, but we don't care about 10. I just care that these two came out equal. I don't care if they're both a million, whatever, they're equal, right? So the 5 made the left and the right equal. The 5 is a valid answer. So the answer is only 5. Not the -6. Is that good? Everybody see why 5 works? 5 makes the two sides equal. 5 makes it true. Makes the equation true. Questions before I move on? Here we go. Square root of x squared plus 5 minus x plus 3. Remember the steps I gave you for square root, the square root plan? Step number 1 is root alone. Step 2 is the parenthesis 2 power, parenthesis 2 power. So the first step, here's the wall. And the square root over here is saying, I want to be alone. Right? I want to be alone. Get me alone. Get rid of all this stuff that's over here on my side of the wall, my side of the equal sign, that's not part of my root. Get rid of anything outside of my root so that the root is alone. That's the first step. So that means I'm going to add the x and subtract the 3 from both sides. Or you could just jump them. How about the jump? Remember when I just grab something and jump? What happens when you jump something to the other side? The sign switch. Remember that? Whenever we jump something to the other side of the equal sign, like the old nursery rhyme, the cow jumped over the moon, right? So whenever you jump over the equal sign, just change your sign in the front. Or you can just, add x. If that bugs you. You can just add x and subtract 3. So whatever way you like. The root's alone, and they've switched signs on the other side. Is that good so far? That's step 1. The root is saying, I want to be alone. We got it alone. Now what? Now do the parenthesis 2 power, parenthesis 2 power. Right, second power both sides. Okay. Parenthesis 2 power, parenthesis 2. Rooting cancels squaring. So what do I do on the other side? Write 2 of them and FOIL, huh? We good? Right? On the left side, the 2 was canceled out by the root, so I didn't do 2 of them. On the right side, I got to do 2 of them. Is that good to there? Let's gather some like terms. Minus 3x minus 3x is minus 6x. Now what do we do? What are we always supposed to do when we see x squared? Get a 0, right? When the sea monster rears its ugly head, get a 0, right? But here's the trick. The sea monster's on both sides. That's weird. Normally we just have it on one side, huh? So what do we do when we have the same thing, whatever it is, the same thing on both sides of the equal sign? Subtract it from both sides, and it's bye-bye sea monster, right? It's going to drop out. Because it was on both sides, instead of just one side, it's gone. It's out of there. No more. So all we have is 5 equals minus 6x plus 9. The x squareds are both gone. Because they were on both sides instead of just one side, they weren't able to hang around. We canceled them out from both sides. Everybody good so far? I did do a race. Stuff at the top. if that's okay. Good to there. So coming up here, we good so far? Now, notice what we have. Everybody good to this point, okay? Questions to that point? Is the C monster still here? On the current line I'm on, is there an x squared?
No.
I don't have to get a 0 or any of that fancy stuff. It's not x squared, it's just regular x. I'll just write just x to the first x squared. So what does that mean? Well, just solve for it. You don't have to get a 0 and factor and all that fancy stuff. Just get x alone. What do I do to get x alone? Minus the 9. Is that minus 4? What do I do now? Divide it. And this, the two negatives cancel, huh? And 4 over 6, you can reduce that to be 2/3. Is that okay? Kind of running out of room here. X is 2/3. Is that okay? I just reduced the two negatives canceled, and I reduced 4/6 divided by 2 to be 2/3. Is that good? Yeah, why not? What are we supposed to do at the end of every one of these square root problems? Check it. We have to check it, right? It's not going to check. The answer to this problem is going to be no solution, because the only answer we have won't work, it turns out. All this for no solution, it turns out. This is going to be a no solution one. 2/3 is not really the answer. Remember, every square root problem must be checked. You've got to check. That's why these are kind of tedious. These are hard. So we've got to check. Let's check. So how do we check? You know what? To make it easier, guys and gals, I would just make that a decimal. Just use your calculator. It's 0.666. You know, it's hard to do fractions. We don't want to mess with fractions. Just divide 2 by 3, get 0.666. Check. Where do we always check? The original, right? Go back to the original equation. Square root of x squared plus 5 minus x plus 3 equals 0. Plug it in, so you get square root of, I'm just going to go 3 sixths squared plus 5 minus 3 sixths, because I know the sixths go forever. If you work that out, it'll be no. It'll not be true. The left side and the right side will not be equal.
How would we know when we get this in the test?
How would we know to check?
Yeah, because it doesn't mean no multiple choice.
Yeah, they could be in both cases. There'll be some in multiple choice, some in the non.
On the last 5 where you don't have multiple choice.
Yeah, there'll be one of these in the last 5, and there'll probably be 1 or 2 in the earlier 15 that are multiple choice. Yeah. So you know because the problem started with roots, right? So you should write on your 3 by 5 card any problem that starts with a root and an equals, like I wrote on the board a minute ago. Any problem that has a root and an equals, check. And the way I did things like that when I was a student, and I was really nervous, wanted to do well, and school was pretty much my life, is when I would get the test in my hand, right then, not a half an hour later when I could hardly remember my name, right? Right then, no pressure on me, start looking, I'd look through all the questions to see which ones had a root and an equals, or whatever the thing was I was watching for on that particular test, right? So you'd be watching. It's intentional. This won't come to the casual. The casual will just stroll in, sit down, do whatever, and they won't get it. No, they won't do well. But those who really want it, will come in with a game plan. And they'll take that exam in their hand and they'll look through, and any problem with a root and an equals, they'll circle it. That's what I would do. Circle it right then. First minute of the test, I'd circle it, or I'd write a C next to it, so that I would remember when I came to that problem, I got to check it. So that you can do if you want it bad enough. If you care, then you can do that. And that's what it takes. It's going to separate those who care that much from those that don't care quite that much. That's what will happen with this question. Make sense? So any problem that begins with a root, it's got to be checked. So the answer doesn't check, so it's a no solution on that one. It's a no solution.
Will we get something like this on the test with a fraction on it?
Oh yeah, it could be. Yeah, it's fair game. Yeah, anything we do in homework is fair game for tests.
What did you do right there on the bottom?
Right here?
If I get one like this, how would I know it's no solution down there? Did you solve?
Oh, that was just, yeah, a calculator. Yeah, I just didn't want to, well, I can't do it in my head. But just, just type this all into your calculator, and hit equals, and it won't be 0. The left side will not be 0. The right side's 0, right? So the only way it's going to come out, the two sides equal, is if they're both the same number. The right side, we already know the number, it's 0. The left side, if you do your calculator, it won't be 0. And so it's not equal. Does that make sense how we check? To be true, when we check something, the two sides must be the same number. Let me look back with you for a second. See, look right here. Let me look back one. See how on the last problem, see the left and the right sides came out different numbers, 1 and -1, so we said no. But on this check, 10 and 10, we said yes. So the answer is not 10. It's whatever we plugged in. 5 worked to make the two sides the same on the last problem. Does that make sense? That's what a check means. You're checking to see if when you plug that answer in, it makes the two sides truly equal. If it does, it's a real answer. If it makes them different, it's not an answer. That's what an answer is supposed to do, is make the equation true. Make the left side equal the right side. Does that make sense? So in this one, I knew it was a no-go because the left side, if you use your calculator, does not come out the same as the right side. I didn't bother. I don't know what it is, but I know it's not 0.
It's because it's a run-on.
No, some run-ons can do that. They can work. Sometimes it can work. That's not really the reason. It's just the wrong run-on.
Well, that's it.
I know you'd like.
It's so much easier.
I know. This is harder here. There's not an easier way. If there was, I promise I'd give it to you. If there was a quicker, easier way, I would give it to you. These are tough. These will separate those who want them more from those who want them less. That's what they'll do. So you can do it. It's in your court. You can make it happen, but you're going to have to give it some time. It'll have to be important in your life. You'll have to give it some time and practice. See Roberto, come to office hours. I'll give you 10 of them. We'll do them for an hour. You'll be able to do it on the exam. Go to see Roberto. Go ask Math Excel to give you 10 of them in a row. It'll make new ones for you. Do whatever, and you can get it down. But it will take some time. It won't come to the casual. All right, let's keep moving. We got a few more things to cover. Is this one better than it looks? Because it looks terrible. Let's see. Okay, so we have the p plus 7, p plus 2 square root minus 3 equals p plus 1. Okay. All right, how are we doing? So as soon as you see a root, what are you supposed to do? When you see that root, what are you supposed to do? What's our game plan? Whenever we see a root, so you want to be looking, let me really encourage you. I write the steps out for you. Try to help. When you have a root with an equals, right? So have that on your 3x5 card. Write on your 3x5 card. Have the steps. Let me write them a little nicer. So when you see a root with an equals, what are the steps? What's step number 1? Root alone. Remember, step number 1 is the root says, I want to be alone. Here's the wall. So the equal sign is the wall. And the root is right here. Right? And he's saying, I want to be alone. So how do I get that root alone? Move the plus 3. Do plus 3 to both sides. Exactly. Does that make sense? 2 plus 3. Plus 3 to both sides like that. Is that good to there? And then step number 2 is the 2 power thing, huh? Getting the hang of that? You always want to do math in steps. So there's our step 2, 2 power both sides. Yeah. What's that? Oh yeah, look at that, I'm changing the game, huh? Thanks. Don't do that, don't change the problem. Looks like I need a little more practice. Alright, so you get the hang of these root plans, so you get the root alone, and then you 2 power both sides. So the root's alone now, huh? He's the whole left side. Now do a 2 power, 2 power, parentheses. Okay, do parentheses, 2 power, parentheses, 2 power. So parenthesis 2 power, parenthesis 2 power. Rooting cancels squaring. Is that good? The root just cancels out the 2 power. The other side, you write 2 of them. Is that good so far? Does everybody see why is there 2p plus 4? Because the 2 power made 2 of them, huh? Is that good to there? And then we FOIL the left side, we get p squared plus 2p plus 7p plus 14. Other side p squared plus 4p plus 4p plus 16. Yeah, notice we have p squared on both sides, so what's going to happen? Here, let me gather like terms first up. So it'd be what, 9p? What's this? This is going to be 8p. I'm not writing very nice here. Yeah, what's going to happen to the fact that we have the C monster, the p squared, on both sides again? Bye-bye. It's going to cancel out, huh? We just subtract p squared from both sides. Bye-bye. We good so far? Can I erase some of this? We okay? Just a little bit more. So where are we at? We're at 9. Whoops, it's supposed to be a 9. 9p plus 14 is 8p plus 16. Good to there? What do we do now? You know, subtract the lower one, huh? Subtract the 8p, yeah. From both sides, we get p plus 14 is 16. Subtract the 14. P is 2. Maybe. Got to check it, right? Any problem that has a root with an equal sign must be checked. How do we check it? Where do we check it? Where do we check them?
The original problem.
Original problem. Plug in, and what does it got to do to be true?
Equal on both sides.
Equal on both sides, right? So plug in that 2 and see if it comes out equal on both sides or not. So maybe I'll come over here and do the check. I don't know if there's room though. So it's long. Plug in the 2, the 2. So that'll be square root of 9 times 4. That'll be square root of 36. That's 6 minus 3. That's 3 equals 3. Yes. So what does that mean? 2 is a true answer. The answer is not 3, it's 2. By 2, p equals 2, plugged in, made the two sides equal. I don't care what the number is at the end, just that the two sides are the same. They're equal. Does that make sense there? Did I do that check too quick?
Yeah.
Square root of 36 is 6?
Yeah, how did you get the 9 times 4 and 5?
I'm plugging in 2 for the p. See the 2?
Yeah.
So 2 plus 7? 2 plus 2? It's 4.
Okay, so you don't actually.
So I'm just plugging in. Yeah, you don't have to foil. When they're just numbers, you can just add them. Yeah, good question. Yeah, you don't have to actually foil it because they're just numbers. You only have to foil when one's a letter, one's a number, huh? So I can just add 2 and 7 to be 9, and 2 and 2 to be 4. And 4 times 9 is 36. The square root of 36 is 6. Yeah, you know, with the check, you can just do it all calculated, really, because it's all just pure numbers. There's no letters. There's not really any algebra rules. There's no letters. So the check is just all numbers. You can just use your calculator and just calculate, you know, the numbers. It's all just numbers. Just make sure the left side and the right side are really equal. What if they come out not equal? What if it was like 3 equals 7 or something, and they're not equal? So there'd be no solution. If you have 2 answers and one of them is bad, you just keep the good one. But if you only have 1 answer and it's bad, that's no solution. Good questions I can answer? All right. Yeah, is everybody okay with? I can flash it back on the screen. Is everybody okay with that one? Everybody get it all copied down? P equals 2 was the answer. That is true. All right, so this one's a bugger. I know we felt like the other ones were bad. This one's worse. These really do get tough here at the end. But you can do them. They just take a lot of practice. So, all right, so square root of x minus 13 equals 13 minus the root of x. All right, so this one's a double rooter. It has 2 roots. That's why he's so hard. All right, here we go. What's the first thing we're supposed to do? 2 power, right? Right, so let's 2 power. We're supposed to get the root alone. The root already is alone on the left side. You might say, well, yeah, but the root on the right's not alone. That's the best we can do. There's only 2 sides, left side, right side, and there's 3 items. No way everybody's going to be alone. So it's that. In fact, that's the problem. That's why this one's going to be so awful, because we can't get everybody alone to start with. So we just have to dive right in. Parenthesis 2 power, parenthesis 2 power. Okay, what happens? Rooting cancels squaring. Good to there?
But next one you have to distribute, huh?
Good job.
169.
You got to write 2 of them. Like that. Remember, you always have to write 2 of them like that. Everybody see that? See, on the left side, there was just one big root over the whole thing. So it just tore off the root. No big deal. But on the right side, there's 2 things. There's a 13 and a minus root x. You got to write parentheses and FOIL and all that. Okay, so here we go. 169 minus 13 root x. Remember the outsider, 13 stays outside, and the root x stays inside. Minus root x times minus root x. Negative times negative is positive. Plain x, huh? Because root x is plain x. Remember that? Remember the 2 roots make a plain whatever? Root x, plain x. We good to there? Now, what is am I racing ahead? What is minus 13 root x minus another 13 root x? Yeah, they're like terms, you just add them up, huh? Minus 26 root x. We good to there? Okay. Good job. Exactly. Yeah, it can be really confusing at this point, huh? As you look at this thing, you could be like, what are we even supposed to do? It's not looking like it's helping. It looks worse than it started. But actually, it is messy, I agree, but it is slightly better. How's it better? We've only got 1 root now, not 2. You see that? You have the root x here, and there's no root over there now. So we did get rid of 1 of the roots, but we still have another one. So what do? Get that guy alone. This guy right here, he's saying, I want to be alone.
Before you go ahead, I have a question.
Mm-hmm.
So, you know that negative 13 square root of root x minus 13 root x? Wouldn't that make the square root go away if we combine those? You know how we did that like last week where we combined those 2 and those root went away?
Are you talking about over here? The right side?
No. Underneath.
Down here? Oh, these 2. Why isn't root x
Above that. In the middle.
right here?
Those 2 root squares, wouldn't they combine
To be a regular x.
go away and make a regular x?
When they're multiplied, not when they're added, subtracted. Good question. Make sure you know the difference, or it's death on Wednesday. I'm not trying to be mean, but I want to say that cancer will kill you. It's a great question. I'm a doctor. That's a great question. Know that, or that's the kind of thing that death. It's a great question.
I would have automatically done
Yeah,
that.
so you really have to be clear for the exam, and that's not just this section, that's everything we do. There's certain rules for adding, subtracting things, and there's different rules for multiplying, dividing. So whenever I give you a rule like 2 roots make a regular, you need to think, is that a rule for multiplying, or is that a rule for adding, subtracting? Always in algebra, always. You want to be, don't just think, that's a rule that's always true. No, that's a rule maybe for multiplying, dividing, or maybe that's a rule for adding, subtracting, but never always. Never always. Does that make sense? That's a great question. Everybody see that? All the rules you want to know, is that a rule true for multiplying, dividing, or is that a rule true for adding, subtracting? Because they're different. So good question. Yeah. Why? I see that all the time in the exam. I'm sure she's not the only one with that question. It's a very good question. I see it. I'm glad we can address it for a second. 2 roots of x. Don't 2 roots make a regular x? Yes, when they're multiplied. Not when they're added, subtracted. Right? So that root x, regular x, that's times, not added, subtracted. You've got to know that, or it's just going to kill you on Wednesday. Practice that practice exam, and you will know that. Go back over the homework as you need to, and you will know that. So, right? So, good question. So, minus 13 root x, minus 13 root x is minus 26 root x. That's a really important issue. Got to know that. Yeah.
I think we need to test just on the income.
Just put it, but that would be nice, wouldn't it? It itself is like got everything, doesn't it? All right, so we did here. Now, what are we supposed to even do now? We got a root. What do we always do with the root? I want to be alone. Get rid of everything else that's with me. All right, so get rid of this 169 and get rid of this x. Bye-bye. And whatever we do to one side of the wall, the equal sign, we have no choice but to do the same thing to the other. Minus 169 and minus x. See how I'm doing the same thing to both sides? And I'm doing what will get the root alone, aren't I? So these cancel, x minus x, gonzo. And what's that going to be? What's that, 182? Minus 182? Oh, the root's not quite well. Let me slow down. Everybody good so far? See what am I trying to do? The root is saying, I want to be alone. That's what he's always saying, huh? Whenever you got a root, he's always saying, I want to be alone. Get rid of all this stuff that's with me. So I got rid of the 169. I got rid of the plus x. I do an opposite, opposite. And whatever you do to one side, no choice but do the same thing to the other. X is canceled. These add up on a calculator to be 182.
Now, can you square that?
Well, the root's still not alone. I'm almost alone. I'm almost alone. Get rid of this thing. I want to be alone. So how do we get rid of that minus 26?
Square root again?
Divide, right? That's times, right? That minus 26 times the root.
That's so easy.
So divide it on both sides. On that. And then, is that 7? I think it's 7, isn't it? Positive, regular, set. 2 negatives make positive. Calculator? Is that what it is? 7? So we're not done yet. We got the root alone. And now we got to get rid of the root. How do we get rid of that root? Now we do the 2 power. Now we do the 2 power. 2 power, 2 power. What does 2 power do to a root? Cancels it. X is 49. Maybe. We have to check it. After all that, we still have to check. Yeah. So let's check it. It'll actually be an easy check. It will check. It is the right answer. So let's go back to the original. Plug in the 49. Plug in the 49. Yeah. It's the root of something. 36. What's the square root of 49? 7. 6 equals 6. Yes. The answer works. 49 is the real answer. See how when I plugged in that 49, it made the two sides equal? It's the real thing that balances the equation. It's the real answer. Are we good? Questions on that one? Was that your favorite one so far? All right. Can I move on? Y'all got it copied down there? All right. Triangles. Much easier section. All right. So they're going to give us a right triangle like this one. So what do I do with that right triangle to solve for C? Do you remember any formulas that work?
A squared plus B squared.
Yeah, do you remember that one? A squared plus B squared is C squared. Do you remember that thing?
Yeah.
When can we use that? For any right triangle. So for any right triangle, you can use A squared plus B squared is C squared. C has to be the hypotenuse, which means it's the longest side. You can tell C is the longest side here, huh? So the other two are the 8 and the 15. Doesn't matter what order you put them in. That good so far? These will be way easier. We good so far? 289 is C squared. What do we do now to make that into regular C? What gets rid of a 2 power? A root. Have you noticed that roots and 2 powers are the opposites of each other? They're like a poison and an antidote. So if you have one, you do the other. They cancel each other out. So if you have the 2 power, then you root and it goes away. Or if you have the root, you 2 power and it goes away. So whenever you see one of these guys, you do the other guy. That's a lot of what they want you to see. So I'm just going to root both sides, and the rooting cancels the 2 power out and just gets me regular C. Hit the buttons in your calculator, 17, right? 289, square root of 289, isn't it 17? And that's our answer. We're done. Don't need to check. Don't need to mess around. No factoring, no zero. We're just done. C is 17. Is that good? Questions? All right, let's try now. All right, so try that one. You're trying to find B there. That's a B on the right side. Same formula. So use the same formula, a squared plus b squared is c squared. So a squared plus b squared is c squared. So that would be, so the a, b, c, huh? It's an a there. So that's 6 squared plus b squared is 10 squared?
Yep.
You guys get the answer 8?
Yeah.
Good. 100, how do we solve for b?
Subtract 36.
Subtract the 36. So b squared is 64. Root it. B is 8. Right, that's how you turn a b squared into a regular b, huh? That's how you get rid of a 2 power. You root it. So you see in the theme here that 2 powers and roots are opposites of each other? They get rid of each other? Questions on that one? These are better, huh? This is a much easier section. They're all just like this. Let's do a couple more. And I think we've got this section. Okay, try that one. They want you to find the A. A and 1 and root 26. So a squared plus b squared is c squared. This is a, b, c. So 1 squared and root 26 squared. Good so far? One squared is 1. What's the root of 26 squared? Yeah, remember? Roots and squares cancel. It's just plain 26. Does that make sense there? So why don't I actually take 26 times 26? Why don't I do that?
Yeah, the root.
That'd be a really good question. Anybody?
Because
Have an
you'll
answer?
still get the same answer.
26 times 26 would be a very different answer.
Right, but if you're doing 26 times 26, you'll still get the square root to 26.
So what I'm asking is, why aren't I multiplying 26 twice here? Right? Isn't that what that 2 is supposed to do?
No, okay, the
The
root.
2 was canceled out by the root.
Oh,
Right? We all good with that? That's why I didn't do it. Remember, the root cancels the 2. Roots and 2s are opposites, antidote and a poison, right? So like I take the poison, why don't I die? Well, I was given the antidote. Right? So the poison couldn't do its thing. Right? The 2 power couldn't do its thing. Why not? The root canceled it. That's why I'm showing that canceling up there. Right? The poison couldn't do its thing. The antidote came in and neutralized it, right? That's what roots and 2 powers are. They neutralize each other. When they're both there, nothing happens, right? Is that good? And then we just subtract 1. So a squared's 25. How do we turn that into plain A? We root it, because the rooting will cancel the 2 power. And that's 5, huh? A is 5. Does that make sense? Good with that? Everybody see that last step? So whenever you have a 2 power, how do you get rid of it? You root, but you got to do both sides, huh? And the root cancels the 2 power. Makes it a plain A. That good? You getting the hang of 2 powers and roots, how they're always the opposite? So whenever we have one of them, we do the other one, don't we? Then they'll cancel each other out. That good? All right. All right, so try that one. Same formula. We just keep using that formula over and over and over again. A squared
that last
plus
one
b
was
squared.
number 4?
Yes, it was.
We didn't do number 3?
Oh, yeah, I skipped number 3. It was too easy. Too easy. spend our time on the hard ones. A squared plus B squared is C squared. So plug in the B and the C.
So if you square the B term, 2 in equals 1 out, right? So it's just
Right.
6 times 3.
Almost. It's 6 times 6 times 3. There's 2 sixes also, right? Two sixes already out. So A squared and then B is 6 root 3 squared equals C squared, 12 squared. Everybody good to there so far? I just plugged in B and plugged in C here with parentheses around whatever you plug in, right? I don't have an A yet. So far so good? Just plug in B and plug in C? Okay, so now how do you square this? What does a 2 power mean? It means write 2 of them, doesn't it? So you square the 6, that's 36, right? 6 times 6. And what do you do with the root? Cancel it. Plane 3 equals 12 times 12, 144. Yeah, so what is 6 squared? 6 times 6, 36, right?
Okay.
And then, well, okay, yeah, but what happened to the root 3?
Add the root.
The root canceled out the 2 like it always does, poison in an antidote, and it vanished, and we just have the 3. Does that make sense? And then you just multiply those in your calculator, it's going to be 108. Everybody see what's happening? Subtract 108, what is that?
36.
Thank you. So A squared is 36. What do we do now to make it a regular A? Root it. A is 6. We good on that one. Are we happy about that? Questions on that one? No questions? Good. All right, so an airplane, altitude 4,100, slanted distance, has a slanted directly to the airport of 14,500. So this is 14,500. Find the B. So it's an A squared plus B squared is C squared with big numbers. Does that make sense there? They're giving me the A and the C. Okay. And I'm going to find the B. Just definitely you can use your calculator. Big numbers. Unless you can do those in your head. I'd be very impressed. 1,681,000, right? For the first one? No, I don't know the second one. Thank you. Oh, I hit 0. Sorry. Can you do that if you want me again? I guess I could have typed it in. Thank you. Hold it up here so I don't hit the button. 210.
182 million.
210 million, like that.
Your comments are wrong. For the first one.
Oh, are they?
Yeah. Isn't it 16 something?
What is it?
Isn't it 16, 810,000? I don't, the 16 million? 810,000, right?
Oh yeah, look at my comma. Sorry. You're totally right. Yeah, how about that? Thank you. Thank you. 16 million. Yeah. 810,000. I was making up some new comma scheme. Yeah, really, really big numbers. But the same plan, right? Just subtract that big old 16 million number. 16,810,000 from both sides. So b squared will be this big thing, which I don't know. So we got this thing, 1, I can do that much, 1.
193440000.
Is that right? 19344?
Yeah.
19344 and 4 zeros. Looks good.
That's a big number.
Yeah, looks right to me. Is that good to there? I'll put some commas in there. 193 million. So I've got b squared is 193,440,000. Good. And then root it. Root it. B equals. Anybody got it?
13,900.
What is it?
13,908.
13,908?
That's one.
0.27.
0.27? And they say type exact. Oh, they don't want a decimal. That's a shame. That's torturous. They want this. Square root of 193,440. Let me type that in and see if that's right. Valuable. Okay, find the length of a diagonal of a square whose sides are 7 long. Okay, so they got it. So try that one. Yeah, that's a good question. That does end up on the test sometimes. It might be on the next test. I don't remember exactly. See if those words make some sense for you. So what are the sides?
7.
So that means this is 7, and you're supposed to find the length of the diagonal, C. Does that make sense? So plug in a squared plus b squared is c squared, because that's a right triangle. Right? Good to there so far? See what I'm doing? A squared plus b squared is c squared. So good, use your calculator. 49 plus 49 is c squared, 98 is c squared. We all good to there? Now, bring it up here. Now, how do you finish that? How do you turn that into regular C? Rooted, huh? Yeah, root. So the root cancels the square. Regular C. Now, how do you square root 98? We do have to simplify. Now, these smaller ones I will make you on the test, right? We did a whole bunch of these last week, right? Tons of them. So you know how to, I just didn't want to mess with that crazy one that was up in the millions. I'm not going to give you anything like that. But 98, you should be able to simplify. How do we do it? Remember it from last week? What do we do? Use your calculator and divide by 2, and you'll find out it's 2 times 49. And then the 49 is 7 times 7. Remember breaking down the big numbers last week? So we broke down the 98. It's 2 times 7 times 7. And then what's the deal? How do you come out of a root? Yeah, 2 in, 1 out. 2 7s in, 1 7 out to the front, huh? And what's left inside?
2.
Yeah, that 2, because there was only one of him. There's our answer, 7 root 2. The 2 had to stay inside because there was only one of him. But the 2 7s in sent 1 7 out, and they're gone. You remember all that from last week, right?
You said there'll be something like this on the test?
Oh, yeah, there definitely could be. I don't remember if it's exactly, but I know I put it on tests sometimes. I made the test lab long time. Good. Questions on that one? So we've done it. We covered it all at chapter 8. So 8.5 and 8.6 are due on Wednesday, and we take our 5th and last exam other than the final. So spend a lot of time with that practice exam in these next 2 days. Make the practice exam your best friend. Ignore your other or less important classes, your spouse, your children, your job, whatever. You in that practice exam. Get real close and personal. All right, let's let me click. There we go. So click A for apple. A for apple.